Graphs of linear functions. Yeah, I don't really know how to spice that up. Right, linear functions have no powers higher than 1, so we are not talking about anything that's either squared or cubed or any powers basically other than just x. Okay, these are straight line functions. And we should know the gradient of a line, hopefully, is change in y over change in x, or, you know, I quite often write that if I'm being a little bit lazy as change in y over change in x, but it means the same thing. If I put a little graph up here, you choose 2 points, and between those 2 points you find out what is my change in y. You know, it's gone up 2 in this case, and what's my change in x? It's gone along 3. So what that be? So, you know, we've got 2 here, 3 here. My gradient would be change in y over change in x. It'd be 2/3. Right, so, and we always go from left to right when we're talking about these graphs. So what's happening as we go from left to right? So, which means my gradient can be, in this case, it is positive. It's a fraction, but it's still positive, right? So it goes up. And this is all from left to right, if we are going downhill left to right, then it's going to be a negative gradient because the change in y will have gone down. And if we've got a flat line, then it's got 0 gradient, okay? And some people talk about the lines that go straight up and down, the vertical lines, as having infinite gradient. Do I agree? I don't know. Not sure. Either way, we can have lines that go straight up and down. Right, let's get into it. We can generalize this gradient between 2 points. Here's my 2 points, and I've just used x1, y1 as my first x and y point, and x2, y2. This is just a notation thing for people that haven't seen this before. This is just saying, instead of saying xy, xy, I want to show that they're different. This is the x from the first point, y from the first point, x from the second point, y from the second point. Okay, and we generalize that as y2 take away y1, which is exactly what you would do on a normal graph, isn't it? You do the second y coordinate take away the first, and x2 take away x1, so the second x take away the first x. Alright, that's all this is. You're doing change in y over change in x. Looks a bit funny, but that's all it is. Right, so calculate the gradient between these 2 points, 2, 5 and 5, 20. I think it's a good idea to sketch them roughly, so you just choose a place and you put your coordinate down, and you choose another place where it's going to be a bit higher and it's going to be quite a bit further along, so it might be a bit like that. 520, obviously it's your sketch, you decide the scale. Oops, that's my straight line. Sorry, it's kind of difficult to draw on this pad. So my change in, let's do my change in y. So y2 take away y1. Well, y2 is 20. y1, why am I putting a comma? That's a bit weird. Let's rub that out. Don't know what that was about. Yeah, so my y2 is 20 and my y1 is 5. So it's 20 take away 5. And my x2 is 5 and my x1 is 2. Yeah, it's just absolute clarification. That's x1, that's y1, that's x2, that's, goodness me, that's y2. x1, y1, x2, y2. Clear as mud? Good. Well done. Now my job here is done. Oh dear. Moving on. So we've got, there's my generalized form of the gradient between 2 points. So here's an example. Work out the equation of a line with gradient 2 through the point 0, 1. I'm just going to put a little sketch up just to kind of highlight what we're talking about. So 0, 1 is down here. And then I've put another point, just a general point of x, y. Then let's just work out our gradient then. So our gradient equals the change in y. So that will be, in this case, y2 is just this one here, so y. Take away my y coordinate of the first point. And then my second point here is it's got just x coordinate x. Take away the x1 of the first one, which is 0. And that simplifies to y minus 1 over x. Okay, this is going somewhere, I promise. Therefore, the equation is, well, we know that the gradient is y minus 1 over x, but we also know that the gradient here from the question is 2, so this must equal 2. So a little bit of rearranging. Y minus 1 equals 2x, and then add 1 to both sides, y equals 2x plus 1. Equation of a straight line, right? So it's just a kind of another way that you can approach it. There are other ways, but that, it's quite neat, that one. This result can be generalized, of course, if you're thinking about your y-intercept, because 0, 1 is my y-intercept. It's the number on the y-axis where it cuts the y-axis. It's supposed to be an arrow. We could write this out as y minus c over x minus 0, because if our point here is a generalized point, 0, c, it would be y minus c over x minus 0, which you can rearrange. In fact, let's rearrange that a little bit to y minus c equals m brackets x minus 0. Oh, that's supposed to be a 0. Then expand the bracket, y minus c equals mx, because m times 0 is nothing. And then, of course, if you slightly rearrange that, you get y equals mx plus c. Ta-da! Just proves it. That's all I'm doing. It's just proving it. Right, now in GCSE mathematics, we tend to talk about one standard equation of a straight line, which is just our straightforward y equals mx plus c. But actually, even in GCSE, we're really using at least about 3 of these. And they are things like this. X equals a. So x equals something. For example, that could be x equals 2 or something. All right, well, there we go. X equals 2. There's my graph. It is a vertical graph going through the x-axis at 2. All right, so all such lines are parallel to the y-axis. They're vertical, and they go through the x-axis at their number. Right, so if it's x equals something, it's vertical through that number on the x-axis. And obviously this would continue into the negative world as well, or negative values of y. Right. We also use y equals b, so this could be y equals, and that was a lucky guess last time. I'm going to go 5. Oh, it's 3. Darn. But any example, y equals something. It is a line that's parallel to the x-axis. Basically, it's a line, horizontal line, through the y-axis at this point. There's my y-intercept at y equals 3. Y equals 5 would be up here somewhere where 5 is. It would be a horizontal line straight through there. So those are 2 other types. Then we've got y equals mx. So this is something that's got gradient now, because the letter touching x in this format is my gradient. Here's a couple, so y equals 1/3 x, so my gradient is 1/3. That basically means for every 1 we go along, we are going up 1/3. So 1 along, 1/3 up. And I could drop a triangle anywhere along, and that would be the case. Same for this one over here. If I dropped a triangle from here, if it goes, a little right angle triangle, honest. For every 1 I go along, I'm going to go down 2, and it's got a negative gradient, so it's going downhill. All right, y equals. But the important bit here is also they go through the origin, and they have gradient m, so they go through the origin down here. There's no y, well, there is a y-intercept, and that y-intercept is 0. It's a bit like having plus 0 on the end, but obviously I don't need that. What other ones we got? And we got a standard y equals mx plus c. So these ones, here's a couple. They have they're a gradient of m, so the number touching x, so the coefficient of x is the gradient. So this one has gradient of 3. Basically, every 1 we go along, we go up 3. And it also has a y-intercept. So this y-intercept is -0.5. It cuts through the y-axis at -0.5. And if I went along 1, we would be going up. Oh, no. Whatever that was about. We are going up 3. Okay, this one here, we got y equals minus x plus 1. Obviously, the coefficient is -1. The constant term on the end is 1. So the y-intercept is 1, which is there. And if I go along 1, so 1 along, I'll be going down 1. We're always going left to right. Yep. So y equals mx plus c. M is the gradient, c is the y-intercept. We've seen those. Now in further maths, we particularly like these ones. So you put it all on one side of the equals sign. In this case, we've got px plus qy plus r. We're just saying it's something x plus something y plus a constant equals 0. And we like them to be whole numbers, be integers. So here's one, 3x plus 4y, take away 12 equals 0. All right, this is often a tidier way of writing the equation, so they reckon. All right, and there's some sort of features of this we'll come across in a minute. You can see 3 and 4 actually a feature here, but not maybe in the way you expect. It's also worth mentioning, just so I've referenced them, this is the textbook I work on in my school, which is the AQA Level 2 Certificate in Further Mathematics, done by Hodder Education. I am not affiliated to them in any way, but I thought because I used a few of their graphics here from the book for this. So there you go. Go and buy it. It's brilliant. And if they want to sponsor me in any way, I'd be very grateful. But anyway, just so that's where a couple of my graphics have come from. Right, 3x plus 4y minus 12. Let's rearrange it into this form, just to kind of highlight something. So we've now got x divided by something plus y divided by something equals 1. So this is my equation, and first we're going to add 12 to both sides. So all I'm doing is sort of showing you a feature of this particular format. Right? Then we want the right-hand side to be 1, so we're going to divide by 12. Now, 3 divided by 12, or 3 over 12 as a fraction, is the same as 1/4. So that's now x over 4. And 4 divided by, or 4 over 12, I should say, sorry, is the same as 1/3. So that's y over 3, right? I have just divided everything by 12, right? And when I simplify, I get this. Now notice the number under x is the like x-intercept, I suppose, where it cuts the x-axis. And the number under y, the 3, is the y-intercept over there. It is a feature of these equations. So if you put it in that format where it equals 1, you're then going to have whatever the coefficients of x are. In this case, it's a quarter. Oh, sorry, well, not a coefficient, I suppose. Whatever it's over, in this case 4, that's the x-intercept. So whatever it's over on y, that's the y-intercept. Right. Anyway, this is really where we're going. Sketch these lines on the same axes. So I've got 3 equations, y equals -2, y equals 3x minus 2, and x plus 3y minus 9 equals 0. Here's how I would approach sketching these 3 graphs, which is what the next load of questions are all going to be about. Let's just give ourselves some basic axes. Now it says sketch. In maths, sketch means use a ruler, you know, put some straight lines, put a basic set of axes. You don't have to do it accurately. You just have to kind of mark on any relevant numbers that we're talking about. Now the first one, y equals -2. That will be a horizontal line through the y-axis at -2. So I'm just going to mark on -2 down here, and then with my ruler, I'm going to draw on that line. And always label your lines. Y equals -2. Next one, y equals 3x minus 2. What do I know about this? Well, I know it also has the y-intercept of -2. So it'll be down here. It'll be coming from this point, and a gradient of 3. That means for every 1 I go along, it's going to go up 3. So it's going to be a sort of diagonal line, fairly steeply going through this y-axis, like that. Okay. I mean, I could work out my my x-intercept, I guess, and put it down there. But I'm not going to. It's actually about 2/3. Last one. X plus 3y minus 9 equals 0. I'm going to do a little bit of rearranging on this first of all. I think that's what I'm going to do. Anyway, let me refer to my notes, because I don't usually use this one terribly often. Oh, okay, yeah. What we're going to do, when we've got one like this, we could do that thing we just did. We could make it equal 1 and see what the numbers are underneath x and y, and we could use those as our intercepts. Here's another way you could do it, though, which is when it crosses the y-axis, so when this line crosses the y-axis, x will be 0. So if we first of all think about x being 0, we've then left with 3y minus 9 equals 0. Quick little bit of rearranging discovers that that must be when y equals 3, which is there. Or at least I'm going to say it's there. You can see it's, 1 and a bit more times than that. That number down there, the -2, but above. Just try and keep the scale kind of roughly right. Now, when it cuts down the x-axis, probably somewhere over here, I'm guessing, because I know, because I've done the example. It's going to, the y value is going to be 0. So we did x as 0. Now we do y as 0. Now when y is 0, the 3y will disappear, leaving x minus 9 equals 8. This is not my clearest explanation I've ever done. Rearrange it, x equals 9. So somewhere over here, I'm going to say it's there, we've got x equals 9, draw the line through it. Basically, and this will actually work for any of them. If you want to know the y-intercept, that is when x is 0. So you put x is 0, solve it. So all I'm doing is just changing this, subbing into this equation, x is 0, then figure out what y is, that's your y-intercept. If you put y as 0, just into the equation, solve it, that tells you what the x-intercept is, put the line through. This, I think, is easier than making it equal 1, personally. So x is 0, get your answer. Y is 0, get your answer. Sketch it. 3 types of graph. Right, what you're going to do is let me be quiet. And you're going to go and do these. Or at least that's what I'd recommend. From the same book. All right, again, not affiliated by them in any way. This is edition 2, I believe. I think in May 2025, they're going to be putting out edition 3. But for now, this is where this one is. So this is edition 2. Anyway, page 54, exercise 3D. Answers are on 266. Questions 1 to 9. Do as many as you can. Remember, use a ruler. You don't need to be completely accurate with, your spacing. Just keep it. It is a sketch after all, but use a ruler. All right? I'll be quiet now. I'm just off to go and eat some quality street. Bye-bye.